Hi dear students, hope you are all doing good. Okay, so here we are going to discuss today's Brainiacs capsule. So today we are going to discuss the chapter amines. I have taken the three important questions that is expected for NEET 2024. Okay, so all of you go through the question. So the question here is, we need to do a match the following between the column 1 and the column 2 and mark the appropriate choice. This is the question. So in the column 1, they have given a description of the reaction. Okay, and we need to identify which of that is this particular reaction is. Okay, let's go through the reaction. Reaction of benzene diazonium chloride, okay, with cuprous salts dissolved in halogen acid. So we need to identify what is this particular reaction. Next one, reaction of benzene diazonium chloride with halogen acid, okay, in the presence of copper powder. And we need to know which is this particular reaction. Okay, third one, the reaction of amines with the chloroform. It's a very famous reaction. And the last one is the reaction of amines with the benzene sulfonyl chloride. Another famous reaction. Okay, now let's try to match it after seeing the explanation. Okay, now let me start with the concept of the third one, benzene diazonium chloride. That is the main thing here. Okay, we know that in the chapter amines we have the last section that is called benzene diazonium chloride, or we have something, the relation associated with the diazonium salt. And we know that this diazonium salt will undergo in numerous reactions. Okay, so we can see here benzene diazonium salt reacting with copper bromide, okay, copper chloride, okay, so these two, and copper cyanide. These three reactions are very famous reaction, and this is popularly known by the name, can anybody tell that? So this is known by the name, I can say, Sandmeyer reaction. So this is called Sandmeyer reaction. So this one, okay, this one, and okay, yeah, I'll show it like this, and finally this one. So these three are popularly known as what reactions are? I can write it here, that is known as Sandmeyer reaction. Okay, all these reactions are used to prepare bromobenzene, okay, chlorobenzene and cyanobenzene. Okay, and you can see here what is the reagent used, sir. Very, very important. Okay, so the reagent used here is copper bromide, copper chloride and copper cyanide. Okay, now let's see, there are other reactions similar to this. There is an alternate reaction called Gutterman reaction. Okay, that is little different. We will see that. And please see the other important reactions actually. You can see diazonium salt can be converted to phenol when it is treated with water or sulfuric acid, and if you are heating. And you can see this is also getting converted to fluorobenzene if you are treating it with HbF4, fluoroboric acid, HbF4. And next one, you can see this is getting even converted to benzene in the presence of H3PO2, or even you can use C2H5OH, ethanol. That is also possible, ethanol. This is a one-time question for NEET last year. And the last one is iodobenzene if you treat it with the potassium iodide. Okay, so let's see in detail now what is a Sandmeyer reaction. You will understand it very easily. Very simple, ArN2X. Here AR stands for benzene ring. Okay, AR stands for benzene ring, and N2X can be anything, because X here indicates it can be halogen. Okay, this is fundamentally benzene diazonium salt. Okay, this if you are treating with copper chloride in the presence of hydrogen chloride, or copper bromide in the presence of HBr, or CuCN in the presence of KCN, you can convert this into chlorobenzene, bromobenzene and even cyanobenzene. And what is released during the process? Nitrogen gas will be released. Why? Because nitrogen here comes with a positive charge, so it will attract the electrons and move out as gas actually. So we can say that we got the first one. Okay, so that is reaction of benzene diazonium chloride with copper salt. Salt here can be chloride, bromide or cyanide. That is the reason why they are saying cuprous salt dissolved in halogen acids. It can be HCl or anything, HBr or HCl. So I can say the first one is correct. It's a Sandmeyer reaction. Clear? I hope it is clear for you. Okay. Now, next one. There is another important reaction Okay, it is also giving you the same chlorobenzene and bromobenzene, but the difference is here we are not dissolving copper in salt and forming cuprous chloride. Instead, we are using dry copper. Okay, so you can see copper combined with HCl. It is not cuprous salt. So copper along with HBr, it is giving chlorobenzene and bromobenzene. Along with the copper combining with, so here CuX is eliminated. Clear? And this reaction is known by the name, very famous reaction, Gutterman reaction. And the important point you need to remember here is the yield of Gutterman reaction is always less than Sandmeyer reaction. So I can write it here. Yield means the amount you are getting. Yield of Sandmeyer reaction is more than Gutterman reaction. Okay, Gutterman reaction. So which one would be preferred generally in order to produce more amount of chlorobenzene or bromobenzene? Sandmeyer reaction would be preferred. Okay, now let's also see, so we'll do the match the following here. Now reaction of benzene diazonium chloride with the halogen acid HCl in the presence of copper powder. So that is nothing but our Gutterman reaction. Correct? Now let's try to see the other important reactions of diazonium chloride. So I thought of first initially skipping this, but this is very important, so that's why I have added. So you can see when it is treated with potassium iodide, you are getting iodobenzene. Okay, here also the nitrogen gas is getting eliminated. So you can see in almost every benzene diazonium salt reaction, nitrogen gas would be eliminated. That's a clue. Okay, next one, benzene diazonium chloride treated with the fluoroboric acid. So you are getting benzene diazonium fluoroborate. Which on heating you are getting fluorobenzene. Okay, and the last one, when you are treating the same with water, you are getting phenol, sir. You are getting phenol. So it's one of the method of preparation of phenol also. You take benzene diazonium salt and do hydration or treat it with water. Again, nitrogen gas would be eliminated and you are getting what? Phenol. Okay, now the last important type of reaction. So benzene diazonium chloride, when it is treated with H3PO2, I already told, or with ethanol, you are getting benzene itself. The product is benzene. Very, very important. This is the one-time question for NEET already. So that's why this session is very important. Okay, and you can see here nitrogen gas is eliminated. And please remember, with the ethanol, you are also getting aldehyde as the byproduct. Acetaldehyde. This is an expected question. Acetaldehyde. Okay, so I hope this session is clear. Now the last one, even you can prepare nitrobenzene from this one. What you need to do, again with HBF4, we know fluoroboric acid, you will get benzene diazonium fluoroborate. Now if you are just heating, so we have already shown you that if you are just heating this one, okay, listen. So if you are just heating like this, okay, I'm just heating this one. In that case, I can say here I'm just heating this one. So you are getting what, sir? Fluorobenzene in that case. Okay, so you will get fluorobenzene. I will draw that so that you should not forget it. Okay, now if you are heating it with NaNO2, then the story changes. In that case, you are getting nitrobenzene. Okay, in that case, you are getting nitrobenzene. So here you would just get fluorobenzene only. You are getting fluorobenzene. But when you are heating with NaNO2, okay, and copper, you are getting nitrobenzene. So you can understand that if you get benzene diazonium chloride, you can move to any chapter. That's it. Okay, now let's go to the third option, sir. Third option is nothing but reaction of amines with the chloroform and reaction of amines with the benzene sulfonyl chloride. Please remember, this particular reaction is very, very important. That is called Hinsberg reaction. So here you can see it is a test to, okay, I will write there. It is a test. This is a test. Okay, to distinguish between, this is a test to distinguish between whom? 1 degree versus 2 degree versus 3 degree amine. Okay, 1 degree versus 2 degree versus 3 degree amine. Okay, please remember, now we will see which is a reagent used here. Very, very important. In Hinsberg test, we are using a reagent that is called benzene sulfonyl chloride. Okay, it is called benzene sulfonyl chloride. You can see its structure, benzene with a 2s double bond O and chlorine. And now this is treated with a primary amine. Okay, I am treating this with a primary amine. How you know it's a primary amine? You can see here NH2 group is present. Now what is happening with NH2 group? What it will do is HCl would be removed during the reaction. HCl would be removed. So the mechanism I am not explaining. The idea is first H plus will move out, a nucleophile will be generated, and this will attack the sulfur because this will undergo ionization, minus and plus will come. Now when this nucleophile attacks, the chlorine will move out. This is the mechanism. I am not going to explain that. So please just you remember HCl is removed and you are getting what is the product. We can see this product is called, this is similar to our amide, CONH2. Okay. Now in amide, suppose I will help you in naming this particular compound. Many students used to say, sir, it's very difficult to name this compound. So I will take some example and help you. Suppose you are having an amide like this, CH3, C double bond O, NH2. How will you name this compound, sir? We have 2 carbon atoms in the parent chain. So we say, we can call this as ethanamide. Correct? Ethanamide. Now, suppose you are making a substitution in one of this one. One of the hydrogen is substituted. Let's say, one of the hydrogen is substituted with another CH3. So what you will call this compound? Now we will call this as N-methyl. First we will mention the substitution. N-methyl. The remaining thing remains the same. Ethanamide. Ethanamide. Okay. Hope you understood. Now we will go to this particular stuff. Okay. So now we will go to this particular stuff and see. Okay. Listen. Now think like we have a compound. Now the product for us is obtained here is, let us think this is the product. You have a benzene. Okay, and this is connected to S double bond O, and think like it is connected to NH2. So CONH2, here SONH2. This is called benzene sulfonamide. Okay, any doubt? Instead of our normal amide, I am putting sulfonamide. Okay, so what will happen? Now the question is, here I am removing one of the hydrogen. Okay, you can see here I am removing one of the hydrogen and that is replaced with a substitution part, that is C2H5. Now how you will name it? I can say N-ethyl. I can say N-ethyl benzene sulfonamide. N-ethyl benzene sulfonamide. Clear? I hope the method I told, hope you have understood. Okay, so don't worry about, you don't need to by heart this name, you can do it by yourself. Now what is the importance of this particular compound, sir? You can see here in benzene sulfonamide, I can easily say this particular hydrogen atom is acidic in nature. This is acidic. Why I am telling that is acidic? Because if I remove that hydrogen, you know how to test acidity. So if I am removing that hydrogen, let us think I am going to remove that hydrogen. Now what is the remaining structure you are getting? You are getting a structure like S double bond O. H plus is removed means it will be N minus along with C2H5. Now I can easily say this minus charge can enter into resonance here. It can move like this and this can move like this. So there is one resonating structure. In the other one it can move like this and then this can move like this. So the remaining structure, this structure is stabilized by what? Resonance. So I can say this is highly acidic in nature. This particular compound is highly acidic in nature. So I can easily say this would be what? This particular compound N-ethyl benzene sulfonamide is soluble in an alkali. Alkali acid base reaction will happen. That is the best thing we can say whenever you are using primary amine, you will get a derivative of benzene sulfonamide which is soluble in alkali. If it is soluble in alkali, I can be sure that that is a primary amine. Clear? Now, what happens if it is a secondary amine? Similar reaction here, HCl will be removed, okay, as I explained. Now, here one difference is there. Here 2C2H5 is now present. Now, how you will name it? I can easily say N comma N because two derivatives are present. So, N comma N diethyl, remaining thing is benzene sulfonamide. Now, please understand whether this will be soluble in alkali. No. Why? Because there is no acidic hydrogen associated with the nitrogen. There is no acidic hydrogen. So, I can say this is insoluble in alkali. This is insoluble in alkali. This is insoluble in alkali. Understood? So very simple, I can say if you are taking a secondary amine, it will also react with the benzene sulfonyl chloride or Hinsberg reagent, but you will get a product which is insoluble in alkali because this particular compound lacks. There is no acidic hydrogen present. But if you take a primary amine, what is happening? You will get a compound that has acidic hydrogen, so it will be soluble in alkali. Okay, so very simple, take the product, dissolve in alkali. If it is dissolving, I can say primary amine. If it is not dissolving, I can say it's a secondary amine. Now 3-degree amines, what is its case? It will not even react with the Hinsberg reagent. So this will not even react with the Hinsberg reagent. And in NCERT nowadays, one more sentence is added. What is the reagent nowadays it is used? They used to say instead of Hinsberg reagent, they use a new reagent that is called para-toluene. I am writing in a different ink. Para-toluene benzene sulfonyl, para-toluene benzene sulfonyl chloride. So please remember this. Nowadays, instead of Hinsberg reagent, which of the following is used? Then I can say para-toluene benzene sulfonyl chloride is used. So what is the major difference if you say that? I can say here what is present. Okay, I can show you with the changing ink. Then that would be logical. So I can easily say para-toluene benzene sulfonyl chloride means what? Only one difference is present. Here CH3 is extra present. Then we can say that as para-toluene benzene sulfonyl chloride. Okay, so that is all about Hinsberg reaction. So now let's discuss the match the following. Reaction of amines with benzene sulfonyl chloride is known by the name. I can say that is called my Hinsberg reaction. That is called my Hinsberg reaction. Okay, next one, reaction of amines with the chloroform. Okay, so the next one is reaction of amines with the chloroform, very famous reaction, and this is known by the name carbylamine reaction. It is a test. It is a test to check. It is a test to check if the given amine, is 1 degree or not. What does that mean, sir? So you are given, you don't know which amine you have taken. If it is a 1 degree amine, this 1 degree amine can be either aliphatic primary amine or it can be even aromatic primary amine. Both of them, if you are treating with chloroform in the presence of alkali, what will happen? You will get a foul smelling. You will get a foul smell. That is the indication. Foul smell. Why the foul smell is happening? Tell me, sir, why the foul smell is happening? The foul smell happens due to the formation of isocyanate. This is an isocyanate. Alkyl isocyanate. There aryl aryl isocyanate. Okay, I should not write R here. That is wrong. It should be benzene. Okay. So here aryl isocyanate would be formed. Okay, you can remove this. Aryl isocyanate. Okay, so it's a test for whether NH2 primary amine means NH2 is present, that is present or not. Okay, so I hope it is clear. So we have answered that question wonderfully. So what is it, sir? So the fourth one is the third one is here, this one. Now tell me which is the option. You have A1, B2, A1, B2 and C is fourth one and D is third one. So option 4 would be my correct answer. Okay, clear? Hope it is clear for you. Okay, now let's go and discuss, or let's discuss the next question. Okay, next expected question from this chapter, that is very important reaction. So here again I am taking phenol, and again it's one of the reactions of diazonium salt only I have taken. So diazonium salt had a reaction with the phenol. It's a very famous reaction. These type of reactions are called coupling reactions. These type of reactions are called coupling reaction. Very, very important. And what type of reaction it is? There are two types of coupling reaction. One is the phenol reacting with the benzene disonium chloride, and other is the aniline reacting with benzene disonium chloride. They are called coupling reaction, and the mechanism followed in this type of reaction is electrophilic substitution reaction. This is very important. I am expecting this for this year's NEET exam. Question may come like the reaction of phenol with benzene disonium salt is an example for nucleophilic substitution, electrophilic substitution, like that they can ask. So the answer is electrophilic substitution reaction. And what is the output product, sir? Already shown in the options. What is that? Dye formation occurs. Either you will get orange dye or we can say yellow dye. I will tell you one shortcut to remember this. Phenol, all is present. All. So we can say thing like the dye would be orange. You can think like that. Okay. And if it is aniline, you can say the other color, that is yellow. You can think like that. So I have mentioned the reaction here. You can see benzene disonium chloride reacting with the phenol. So what would be eliminated, sir? Here water would be in the presence of an alkali. So water would be eliminated, and nitrogen gas, you can see here nitrogen, it is forming the linkage. You can see this is the azo compound, or this is called azo group whenever nitrogen having double bond with nitrogen with a single bond. So azo. So that's the reason why it is called, since OH is present, we say para-hydroxy azobenzene. And I told the way to remember it is an orange dye because OH is what? All. Okay, all. So you can start with O, orange dye. Clear? Very simple. Okay, now I have taken the other reaction also. Let's discuss this question. So what is the answer, sir? Here I can say, if you see from the option itself, you can understand the answer would be option 2 would be my correct answer. Okay, so this is my orange dye. This is my orange dye. Clear? Now let's discuss the next coupling reaction. So you can see here again, only one difference is aniline is taken here. So aniline. I told there are only two reactions mentioned in the text with this. So here also it is an example for what sort of reactions are? Electrophilic substitution reaction. What it will result in? It will result in dye formation. Dye formation. And what sort of dye you will get? Yellow dye. Okay, so the only difference is NH2 will come into picture. So I can easily say option 2 would be my correct answer. There is no other change for this reaction. So you can see this is also mentioned in the textbook. You can see that. So benzene disonium chloride is given, aniline is taken. Again, you can see Cl minus is liberated, water is liberated. Along with, you can see azo linkage. So we can say here para amino azobenzene. That is nothing but yellow dye. So please remember, amino comes with yellow color, and or all for alcohol comes with orange color. Okay. Now the last question for the day. Benzylamine is a stronger base than aniline. Why? Because, very important question. So let's understand the structure of benzylamine. So benzyl group is nothing but C6H5CH2. So this is called my benzyl group. This is called my benzyl group. Now this benzylamine, if you see here, there is lone pair is present. Lone pair, again single bond, again single bond. That means there is no conjugation. There is no conjugation. If there is no conjugation, what will happening? I can say there is no resonance. No resonance means there is no delocalization. No delocalization. So what is the advantage of that? If there is no delocalization, what is the advantage? I can easily say this lone pair will not enter into resonance with the benzene. And the advantage is this lone pair is here localized. Localized means it is full time available there. That means this can be easily donated. Somebody who is capable of donating the electron pair is called a good base. Is called a good base. Suppose if this is entering into resonance, that means it will move, it will keep on delocalizing at different positions. Then this is not available for donation. Then it is a bad base. Okay. Now let's see the structure of aniline, sir. Aniline, you can see here lone pair NH2 directly connected to benzene. You can see lone pair, single bond, double bond, again single bond, double bond. So that means there is a conjugation. Alternatively, you are getting single bond there. Okay, along with the double bond or lone pair. So what will happen? First, the electrons will move towards here, towards the pi bond. So when it comes here, what is happening? This carbon will have 5 valencies. So this will get repelled and it will come here as a negative charge. Now again you can see negative charge, single bond, double bond. So negative charge will move towards here, towards the pi bond to form a, so here this will have 5 valency. So this will get repelled and it will form a negative charge here. When negative charge is here, again conjugation is present. So it will try to move towards the pi bond like this. So this carbon will have now 5 valency. So this will get repelled and come here as a negative charge. And this will again comes here, then this will have 5 valency. So this will be repelled back as a lone pair, you can see here. So that means this lone pair is not available, sir. Most of the time in this structure it is not there. In the, here only one pair is okay. I have drawn here, right? Sorry, let me rub this. This is not available. Okay. Okay. So you can see here not available. Nothing is present here. Here also not available. Here also not available. It is again coming back at this one. So that means less availability of lone pair. That means it is aniline is a bad base. Okay. So let's check at the options. Benzylamine is a stronger base. They are telling itself it is a stronger base than aniline. Why? The lone pair of electrons in nitrogen atom in benzylamine is delocalized. They are telling it will move. No, that is wrong. The lone pair of electrons on the nitrogen atom in aniline is delocalized. That is correct, sir. So that is the reason why benzylamine is a stronger base than aniline. Because aniline is a weaker base because its pair of electrons will undergo delocalization. Okay. So I hope today you have enjoyed today's amines session. We will come up with more chapters and more questions tomorrow. Okay. So those who have liked our video, you can subscribe our channel, and those who feel like, okay sir, we are interested in offline classes, you can directly contact Brainiacs Classes. Just to type in Google, you will get the entire details. You can go to our website and see, and also you can search it in YouTube itself. Most of the classes are available. Okay. So enjoy, work hard for NEET 2024. Thank you.